Today we are going to start our fifth unit, which is application of DIP in different domains. So here we are going to see the applications of DIP in different areas like satellite, radar, sonar, and then applications of DIP in medical areas. So in one of the categorization, we can divide our images in two categories, that is images having single channel and images having multiple channels. So examples of single channel images are our binary images and grayscale images. So where we have a single frame or a channel representing the entire image. But in case of multiple channels, so take an example of color images. So where we have three channels, okay, one representing the red content of the image, another representing the blue content, okay, and the third one indicating the green content of the color image. Another example of multi-channel images is satellite images. Okay, so where we have dozens of channels, okay, representing different information in each channels. Okay, so now in our regular imaging, we capture the image using only visible band. Okay, and why we capture the images in different bands? Consider suppose you are taking one aerial image, okay, and clouds are present. Okay, now you are taking a aerial image of this place, okay, and because of this clouds, if you take the images in visible band, okay, so that place will be occluded by this cloud, right? Okay, that's why for such application generally we take images using microwave. Okay, because of their higher wavelength, okay, they can penetrate through these clouds and we will get the image of that place. Okay, so in this electromagnetic spectrum, if you go from left to right, okay, there will be a decrease in frequency. Okay, frequency decreases, okay, and wavelength increases. Okay, so wavelength, which is generally represented by lambda. Okay, so this radio wavelength will have the highest wavelength. So this is how we can, if you have the sensors capable of taking images in different band, okay, so you can capture images in different bands, okay, and you will get different information in each band. Now let us talk about satellite imagery. Okay, so obviously these are the images which are captured by the satellites which are orbiting around the earth. Okay, generally if you consider the low orbiting satellites, they will be orbiting at a distance of around 600 to 700 kilometer above the earth. Okay, now how these satellite images are different from our regular images. Okay, so typically these satellite images will be very high resolution images. Okay, generally the number of pixels in this satellite images will be more than 10 to the power 4 pixels. Okay, so what is the advantage of this? So actually you can zoom in this picture and see the actual objects present at the earth's surface. Okay, so you can see the buildings and cars, but the disadvantage is that, so if you consider the object like car, okay, they will be represented in the satellite image using very few pixels, around 5 to 10 pixels only. Okay, so you cannot identify one individual object, okay, means one particular car, but you can get the idea that yes, car is there, building is there, their relative position. The next one is they have more number of channels. As we discussed earlier, they will have more number of channels, and these images are geo-reference images because these satellites captures the images of a particular place at a particular time. So if you take an image, after some time you will get the image of some different place. Okay, so these satellite images are typically geo-reference image, and this additional information like this geo-referencing will be stored in the metadata along with that image. Okay, metadata means what? Additional information about that image. So this is one example of multi-channel imaging, a satellite image. Okay, as you can see, we are getting different information in each channel. That is why we capture the images in multiple channels. Okay, as you can see in this two images. River part of the image is clearly visible, and these three images are showing the vegetation part of the place. This is another application, that is weather forecasting, and this is the image of Hurricane Andrew taken by the satellite. Okay, so this is the list of applications of satellite images. First one is the meteorology, which deals with majorly weather forecasting. Second one is oceanography, that is the study of oceans. Then fishing, agriculture, biodiversity conservation, forestry, geology, regional planning, education, intelligence, and warfare. Now let us talk about radar imaging. So we know that radar is an acronym, stands for radio detection and ranging. Okay, so it basically works on the principle of echo. Okay, so there will be a transmitter. Okay, so there will be a transmitter in the equipment. Okay, and that it will emit some high frequency rays. Okay, and that will be reflected from some object. Okay, and the energy reflected will be captured by the receiver. Okay, and the image will be formed. Okay, so it is a system for detecting an object by sending out pulses of high frequency electromagnetic waves that are reflected off the object back to the source. It is capable of detecting presence, direction, distance, and the speed of the object. And what is radar images? Okay, so it is the images produced by the radar system. Okay, so if you form an image using this technique, that is known as a radar image. Okay, so now let us see the process of radar image acquisition. Okay, so there will be one equipment. Okay, there will be one transmitter which will transmit the high frequency wave. Okay, so an imaging radar system emits discrete radar pulses that are directed to one side. Okay, so here we generally use radio waves or microwaves. Okay, so these microwaves interact with the surface objects, and some of them return to the radar antenna. Okay, so the rays which are reflected from the object will come back. Okay, now the travel time will be different for different objects. Okay, and the energy which is reflected back will be also different. Okay, so the system records the echoes from the terrain and their variation in the strength with travel time. Okay, the return signals are positioned according to their time. Now various applications of radar imaging is surface topography. The drawback of radar imaging is that we will not get very clearer images here. Okay, so generally we have a speckles. The noise in radar images is generally known as speckles. Okay, it can be a bright spots. Okay, so some objects will reflect more energy. Okay, so we'll get bright spots in the radar images. Okay, so generally they are used for the surface topography, where we can see the hills and valleys on the earth's surface. Then weather monitoring, and then it is generally used for detecting oil spills from the containers. This is another application, microwave imaging. Okay, so this is the image of the Himalayan hills. Okay, taken in the Tibetan region.